Right. Non-broadcast multi-access modes. Earlier we saw point-to-point and multi-point or broadcast or LAN. In point-to-point what we learned is there is only one multicast address 224.0.0.5 needed because there is no DR/BDR. In LAN, which can also be called as multi-access or multi-point or broadcast, network type broadcast, there we have DR/BDR. As a result, we need another multicast address to identify DR. For that, the multicast address reserved is 224.0.0.6. So in broadcast network type, we have two multicast address 224.0.0.6 only to specifically communicate to DRs, and to others it is going to be 224.0.0.5. Secondly, what we learned is NBMA mode. First is point to point, next is broadcast, and now we are in NBMA mode. In NBMA we have 5 modes. The first one we call it as non-broadcast mode. Non-broadcast mode. The second one is point to multi-point. Now these two modes are RFC, means industry standard. RFC standard. The other 3 which we are going to see are only seen in Cisco. Cisco proprietary features. The third one is what Cisco puts these two together like this. Point to multi-point non-broadcast. You see, non-broadcast and point to multi-point together. We have point to multi-point non-broadcast. This is the third type in NBMA mode, and this is the first Cisco created mode. Cisco's NBMA mode, point to multi-point non-broadcast. See the name, it is using these 2 words. The second one and the first one. But this is not going to have all these 2 have. The best of these 2 will be there in the third one. So we have non-broadcast, we have point to multi-point, we have point to multi-point non-broadcast, which is a Cisco proprietary feature, which is the combination of the above 2, which is best of the above 2. We'll talk about that in detail. Let us finish all 5 types now. Fourth one is broadcast. please understand, this is NBMA mode. In NBMA mode, this is broadcast. Earlier what we saw is network type broadcast. Network type broadcast is what we have a Ethernet network and many routers are connected via a switch, and there will be DR BDR election. That is broadcast, network type broadcast. This one is NBMA. It's not truly a it is not truly a broadcast network. It is not truly it is not a broadcast network. It is NBMA network. In NBMA network, if you wish to have a broadcast experience, in another simple word, if I need to say, if you want NBMA to behave like a broadcast environment, like sending hello packets every 10 seconds, forming DR BDR. If you wish to have those things in a non-broadcast environment, you can go with this mode called broadcast. See, in Sweden, there is a place, a big mall. Inside the mall there is one big food court. In that one food court there is one, I think it is Madrasi chicken, something like that. Madrasi restaurant, something like that. If you go inside, you will get only Indian dishes, Indian food. Dosa, idli, sambar, soru, kolumbu, all you will get. But is it India? No. It's Sweden. But you get India experience, taste of India. Likewise, it is non-broadcast multi-access environment, but you wish to have a broadcast experience. For that, you may need this mode. Do you understand when you need this?
Yes, sir.
Now, next is point to point. Again, it's a non-broadcast environment, but still you want to have a point-to-point experience. Then you need this mode called point-to-point. Now what I'm going to do is I'm going to break these things in more detail one by one.
Okay.
We saw the first one as non-broadcast. When you enable frame relay, on the serial port, when you enable frame relay on the serial port, it becomes a non-broadcast environment. FR, frame relay, on the serial port. In non-broadcast environment, when you enable OSPF now on the same port, the network type will be non-broadcast. So this is the default. This is the default network type. When we enable OSPF on serial port that runs frame relay, the default network type in OSPF is non-broadcast. That's the first mode in NBMA, right? Non-broadcast. That's the default. I did not configure non-broadcast. It is by default. When we enable OSPF on the port where a frame relay is running, we call that as non-broadcast. So the default networking mode is a non-broadcast, which we did not configure. It is there, but it comes by default when you enable OSPF on the frame relay running interface. Frame relay encapsulation type interface. Now what is the difference? This is what the differences are. The first difference is in non-broadcast the timer is not 10, it is 30. Hello timer is 30 seconds. And the dead time is 4 times of hello. Then it is 120 seconds. Second, another difference is neighbors need to be configured manually The reason is non-broadcast. Because it is non-broadcast, OSPF is designed not to send hello packets to multicast address. It is designed not to send multicast address. It will not send. It will not send traffic using multicast. So OSPF cannot be discovering the neighbor automatically. OSPF cannot discover the neighbors automatically. We have to configure neighbor manually. We need to configure. Next difference. There is going to be a DR and BDR election. Because there is DR and BDR election, the network, the frame relay network need to be fully meshed. It need to be fully meshed. If it is not fully meshed, then you should not go for this default mode non-broadcast. We have to change the mode. Understand this. If we are not having a full mesh frame relay, see, on those days we had frame relay. Nowadays we don't have. On those days we had frame relay, and those days I have seen partial mesh or hub and spoke or partial mesh. It was very rare to see full mesh. Why? costly because frame relay is very costly. Now doing full mesh is more costlier. What is full mesh? Forming frame relay tunnels with everyone, not only between hub and spoke, even between the spokes. No one was ready to do between the spokes. We did between hub and spoke, and if one spoke wants to speak to another spoke, it will be through hub. I think you didn't understand.
Yes, sir.
This is spokes 1, spokes 2, spokes 3, hub. Forming frame relay with this, and with this is hub and spoke. Forming frame relay also between spokes. This is full mesh. Full mesh was not seen in the frame relay days because of costliness, very costly. If spokes 1 want to talk to spokes 2, it will go to hub and hub will direct. Hub will forward.
Direct.
Now, because there is DRBDR, this hub and spoke design is not enough. So you should change some other mode actually. This mode, non-broadcast mode, is not enough. Not a suitable mode. So we move on to another mode called point to point. Sorry, point to multi-point. Point to multi-point.
Point to multi-point.
Point to multi-point. So in point to multi-point, neighbors are dynamically discovered there is no DRBDR.
No DRBDR election.
Timers are same. And this can be used in hub and spoke. Any topology, because there is no DRBDR. So this is suitable for hub and spoke and partial mesh. The first one is suitable only for full mesh.
Yes, sir.
This can be, point to multi-point can be used in any topology, any design. No problem. Okay, so these are the variations. And these two, what we have seen so far, these two are RFC standard.
RF system.
Now we are moving on to the Cisco standard. Cisco standard NBMA mode. Point to multi-point non-broadcast. In point to multi-point non-broadcast, wherever the word point comes, there is no DR/BDR.
Correct.
And next is, in this, neighbors are not dynamically
Discover.
we need to manually configure. This timer is same. And then any topology. These are the variations between these three types. Now, in all these three types, we see timers as 30 and 120, whereas in the next two that we are going to see, it will be 10 and 40. Broadcast. Same like a normal broadcast, but the difference is this is a broadcast on top of NBMA. This is a broadcast on top of NBMA. Everything is same. Timer is 10 and 40, DR, BDR. Neighbors are dynamically discovered. Multicast addresses 224.0.0.5, 224.0.0.6. All these are same. Same like broadcast. Everything is same like broadcast, but physical environment is frame relay. Now, in this above first four that we have seen so far, all the neighbors will be in same subnet. Same subnet. In all the four that we have seen, neighbors will be in same subnet. But in point to point, neighbors are different subnet. In point to point, everything is same. No DR, BDR. And only one multicast address. 10 and 40. Everything is same like point to point, but it is not truly a point to point. It is on frame relay. We are getting point to point experience. Did you understand the difference between this 5 NBMA mode?
Yes, sir.